Okay, welcome to lesson 89, irrational numbers. You might be asking yourself, what is an irrational number? So let's delve into it. Here's our objective. You can always pause the number and go back. Irrational numbers. I gotta go back to square roots and we'll explain it. We, we got to deal with our perfect squares. So if this is your first video on this channel, please go back and at least watch the perfect squares. I really want you to watch the welcome video and the welcome to numbers and operations. And here's a rule in the note. So roots of non-perfect numbers are irrational. So the reason why I did the squares, and I want you to go back and look. So if we look at a perfect square from the previous page, let's take any number. The square root of, let's say 361, which is 19. And then we take the square root of 324, which is 18. So if we take any non-perfect number, any number that's not on the list from the page before, and take the square root of it, let's say 325 or 350 or 330. Any one of these numbers will not give you a perfect root. They will be all 18 point something, 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 and they will go on forever and ever. An irrational number is a number that does not end and does not repeat. So, and there are other types of examples of irrational numbers that I want to talk about because you will see them in science. But most of the irrational numbers we are going to deal with are going to be non-perfect roots, even roots. Okay, so now we're going to go back to the number system. And remember, we had natural or counting, which started with 1 and went in whole numbers to in positive infinity. Then we added on our whole numbers, which added 0 and went in positive amounts, whole amounts, and added 1 each way to positive infinity. Then we added integers. Then we added the rational numbers. And now we're dealing with irrational numbers. So let's look at what we have. We have 6 divided by 7, 6 over 7, the square root of 8, 0.3, and this long number right here. And let's see what they are. So 6 divided by 7 can be made a fraction. So this is rational. The square root of 8. Well, the square root of 9 gives you 3. The square root of 4 gives you 2. So this is irrational. It gives you a decimal that is non-repeating and non-ending. And also, irrational numbers cannot be expressed as fractions. 0.3, which equals 3 over 10 as a fraction. This can be made a fraction, so this is rational. And that was the key definition for a rational number. It can be a fraction. Its numbers may end or may repeat. But when we get to irrational, here we have 0, 1, 0, 2, 0, 3, 0, 4. We can see that the succeeding number after the 0 is increasing. This number does not end and it does not repeat. So we will call this irrational. Okay. Now, find two irrational numbers between 6 and 7. So how do we do that? Well, there's two ways we can do this. We can square 6 to get 36, and we can square 7 to get 49. And give me any number between 36 and 49 and take the square root of it. So the square root of 37 and then the square root of 45 or any number in between. And that's how we do it. We square the base numbers because we know the square root of 36 is 6 and the square root of 49 is 7. But if we take any number in between 49 and 36, we know that those numbers will be irrational because the definition tells us that any non-perfect root, the root of any non-perfect number will give us an irrational number. All right, let's look at our third examples. Find a rational number between the square root of 21 and the square root of 15. So, the square root of 15 and the square root of 21. So let's think of our perfect squares. 16. After 15 comes 16. Are there two numbers that are the same that divide into 16? So let's think. 16 divided by 8 is 2. 16 divided by 4 is 4. So 4 times 4 is 16. So the square root of 16 gives us 4, which is a rational number. How is 4 a rational number? You can put 4 over 1, or you can make 4 4.0. And these are rational numbers because it can be expressed as a fraction. Okay, so those are our two examples. Meet me at the end of the video for the recap. Okay, so classify the numbers as rational or irrational. Negative 1.4, 1 and 4 tenths. Negative 1 and 4 over 10. I can make this a fraction, so this would be rational. Okay, this number, the second number, may look like it repeats. We got 12, we got 122, 1222, and 12222. So the number is not actually repeating. It's actually changing after the 1. So this would be irrational. A non-repeating, non-terminating decimal. The opposite of the square root of 16 equals negative 4. And we can show you earlier how 4 can be made rational. And 2.8 divided by 0.13. 2.8 divided by 0.13. This is a fraction, so it's rational. And I don't even have to calculate it out. If it can be expressed as a fraction where the bottom is not 0, then it's rational. Find two irrational numbers between 8 and 9. So again, let's square 8, we get 64. Let's square 9, we get 81. So the square root of 65 and then the square root of 66, or any number all the way up to the square root of 80. Any number between the square root of 65 and the square root of 80 will be work. Again, find a rational number between negative 210 and negative square root of 160. So we're dealing with negatives now. So negative 210 and negative 160. So let's think about our square roots. Let's see, 15 times 15 is 225, so that doesn't work. 13 times 13 is 169. So we got the square root of 169. That works. 14 times 14 is 196. That works. The square root of 196 will give us 14. Will give us 13. So we actually have two numbers in between this range. And because these are opposite, we're looking for the opposite. Negative 14 and negative 13 are rational numbers because we can divide them by 1. And also we can put a 0.0 at the end of them to make them rational. So thank you for watching this video. If this is your first video, please subscribe to this channel for all kinds of videos dealing with math content. And if you like it, subscribe and share it out with your friends. Thanks for visiting.